In this video, we're going to review the law of sines, and it's helpful to remember that the law of sines works for any triangle. And we should also be aware of how triangles are labeled. So let's label this one down here. If, for instance, we called this triangle A, B, C, we use capital letters for the angles. And then across from capital A is lowercase a, that's side A. Across from angle B, we're going to put lowercase b, and across from angle C, we're going to put lowercase c. And then we can see the formula. Here we go. If a triangle has sides A, B, and C and opposite sides A, B, and C, then this is always true. The sine of A over A equals the sine of B over B. And we can even add in one more that says that the sine of C equals C. But we only need to use two of these. We never need all three. All right, so let's try this with this problem. I find that it's really helpful to connect what's opposite to each other. So from 42, we can see opposite it is side A. And from 56, opposite it is side 15. And so we can say, oops, let's get our pen. There we go. We can say the sine of 42 is to A as the sine of 56 is to 17. And then we're going to just cross multiply. A times sine 56 equals 17 sine 42. And we just need to divide by sine 56. So A equals 17 sine 42 over sine 56. And we have what I like to call a calculator ready situation. So we'll pull up our calculator. By the way, we must make sure we're in degree mode. I check. I am in degree mode. And so now I can type in 17 sine 42. Make sure you close the parentheses. Divide it by sine of 56. And press enter. And there we have our answer. A equals, let's look at that again, 13.72. All right, let's try another one. In this one, we are looking for side x, and its opposite, oh wait, that angle's not even there, so that's kind of a problem because we're trying to find side x, and it's going to be opposite that angle. Now what we do have opposite each other is, look at this, the 110 and the 15, so we're good to go on that. Now recall that the angles of a triangle add up to 180, so we can take 180 minus 110 minus 20, and that's going to give us a 50-degree angle up here. So now I have what's opposite x, and I can say sine 50 over x equals sine 110 over 15. And across multiply and divide, and we end up with 15 sine 50 over sine 110. And pull out our calculator, and so we've got 15 sine 50, close the parenthesis, divided by sine of 110. Gives us an answer of 12.23. So x equals 12.23. Now in this next problem, what's different is we're going to be solving for theta. And so let's start by seeing what's opposite each other. So across from theta is 18. And then across from 48 is 14. So we're ready to set up our equation. We're all good to go. So we would say sine of 48 is to 14 as the sine of theta is to 18. And now we can cross multiply and divide, or simply multiply by 18 actually, and I'll get sine theta by itself. So sine theta equals 18 times sine 48 over 14. Now this time, when we put this in our calculator, we have 18 sine 48. We're going to divide that by 14. And what we get is this decimal. This is not our answer. This is the sine of theta. I'm going to take a moment and write this down. So it's 0.95547. It's going to go on, equals sine theta. And to get our answer, we have to do the inverse sine of that. So the inverse sine of that answer, we're going to let the calculator do the work. So watch this. I'm not going to type this again. I'm simply going to do second sine, second answer, parenthesis. And that'll give me my answer. I'm just going to drag this over here so we've got record of how we did that. And there's our answer. Theta equals 72.84 degrees. All right, that should get you going on what you need to know with the law of sines.